In this video, we will be talking about a GUI application that I have been developing for like last 5 days or so. It's pretty basic in nature, but I thought I'd share this with you. So the application is called the SolarGUI. It is an application uh, that shows the information about some planets, Sun, Moon, and Pluto included. Uh, Very basic information. So this is the GitHub repository for SolarGUI. If you want to like check it out, make some issues, if you find bugs, or if you want to add something of yours, please open a pull request. Please come and visit. You're all welcome. So let's take a look at what it is. SolarGUI, as I said, a program that contains information about the solar system, planet, moons, Pluto, Sun, and more. There will be more development in the application further down the line. It's a fun little project that I threw together. You can see values of various physical parameters of the celestial objects in standard SI or CGS units and celestial equivalents as well. For example, if you want to see how much mass of Mercury is equivalent to how much mass of Earth, that option is also available there. And currently the SolarGUI application is tested with Python 3.7, 3.8 and 3.9. That means if you have Python 3.7.0 up to Python 3.10 not included, you can run this application in your like environment. So how to install this application? Well, I have published a couple of versions of this application on pip, so you can just use this command pip install SolarGUI 0.1.3a0, and the latest version of Python SolarGUI will be installed. Or if you do not want to install using pip, if you want to manually install, you can download the wheel link, wheel file from here, and you can go to the directory manually and then pip install that wheel. This is the front layout of the SolarGUI. As you can see, we have Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Moon, and Pluto. These are all the celestial bodies for which the data have been gathered. The data is pretty basic: the age, mass, radius, volume, density, surface area, and surface gravity for now. And this is the actual window showing that how the values are represented using different units. There is a drop-down menu. There is a reset button. There are equivalencies. So this is like the basic overview of my application, and now let's start experimenting or working with it. So we open up our terminal, and let's create a test environment for the application. We want to check it if the application is installable in Python 3.7. So we will create our environment in conda create -n. Now I will input the name of the environment, Python 3.7, and I want to install Python 3 version 3.7 in it. So I will go with this. It will take some time, and then it will install Python 3.7 and relevant packages as well. Let's go. Okay. Now if I activate my Python 3.7 environment and go and open up a Python terminal, I can see that the Python version for this environment is 3.7.0, which is what we required. So that's good. So as we saw in here in the README, the proper way to install the SolarGUI, the latest version is pip install SolarGUI 0.1.3a0. So we'll copy it here. So we have downloaded our and installed the SolarGUI application via pip. So now we can launch the application in the terminal from which we have installed the application. Now the thing to remember is if you install an application in an environment, which I highly recommend. You should make a separate environment for testing initially. You will only have access to that application in that certain environment. So for example, here I installed my application in Python 3.7 environment. So I need Python 3.7 environment to be active if I want to use this application. So for now we are in Python 3.7 and I will call my SolarGUI application. So as you saw, we have the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Moon, and Pluto as our like celestial bodies. If I click the Earth button, another window will open up, which as you can see has the parameters listed: age, mass, radius, velocity, volume, density, surface area, and surface gravity, and their respective values as well. The application uses the Astropy library in backend as well, so I have imported the mass value of Earth from that library. Same thing with the radius, and for the other parameters, the volume, density, surface area, and surface gravity, we have formulas. For volume we can use 4 over 3 pi r cube. For density we can use mass over volume. For surface area we can use 4 over pi r square, and for surface gravity we can use gm over r square. So these values are calculated, and these two values are taken from the library, and the age parameter is taken from Wikipedia. So in here, the unit space, we can change the units. For example, if we want to see how much is the age of Earth in seconds, we can turn that on. If we want to see what is the mass of the Earth in terms of mass of Jupiter, we can turn that on. If we want to see volume in a different unit, for example centimeter cubed, for example the density in kilograms per meter cube, and so on. So these are a few units that I have selected, the standard units and some astronomical units as well, to represent or to change the different values. And if we push the reset button, the unit space drop down menus get reset, and the age is also returned to its original giga year value. So let's press reset over here as well. Now the other thing to look at is the equivalencies button. Now if I click this little window pop-ups, and here we can see I have the radio buttons for Sun, for every like celestial object that I have currently like selected for my application. Now each of these radio button will show the equivalent values of the parameters specified here in terms of this celestial body. For example, if I turn on the Earth, we can see that the age is obviously 1 time Earth, the mass is 1 time Earth, and so on and so forth. However, if I select Neptune, it will show the multiple of Neptunes in terms of mass, radius, and all these parameters. So it's like a little like handy tool in terms of seeing what the parameters are in respect to other celestial objects: Mercury, Venus, Jupiter, Neptune, Uranus, Moon, so on and so forth. However, if we want to reset this, we can simply click on the reset button, and there it is. That's all for this video. Thank you for watching.